Hi and welcome. My name is Bob Deibner, Senior Applications Engineer at Corelis. In this presentation, I'll be showcasing ScanExpress Runner, our Jtag test executive. Runner provides IEEE 1149.1 and .6 test execution with optional pin and net level diagnostics, as well as extended features including in-system programming, CPU-based test, and embedded instrument access. Let's get started. Execute the test steps that we generated with ScanExpress TPG. Execute flash generator test steps, which are also integrated into TPG when you have that license. Jet type test steps, which are CPU control. We can execute all of those using either CVF file, that's our boundary scan type test steps. FPI is flash programming, and Jet is CPU control. Jet stands for Jtag embedded test. That's what we call our CPU-based system. And of course, we can pull in third-party files from Xilinx or Altera software. The SVF and JAM file are open standards. In general, if you use Xilinx, you'll want to use SVF. If you use Intel/Altera, you'll want to use JAM or Staple. Each of these files can be executed with ScanExpress Runner. We can do some sequencing, some basic flow control. Those control the software controls the boundary scan controller, which interfaces with the target board or the UUT, and that's how the whole system works. So first of all, we need to set up our controller. The controller configuration window allows you to specify your controller identity, tap voltage. So if you have a board that operates at 3.3 volts, you want to select that. And when I say board, it's your test access port or tap. If it operates at 3.3 volts, then that's what you want to select there. Clock frequency. In general, higher clock frequency is better for performance, but at the same time, sometimes there'll be a limitation. We find that our demo boards generally run between 30 and 40 megahertz reliably, but at the same time, the BSDLs, the boundary scan devices, the BSDL does include a max clock rate, and in general, that's going to be very conservative and somewhere in the 10 to 30 megahertz. If you have a multi-tap controller, specify which taps you're going to be operating. Once we define that, we can specify our test plan. So the test steps that we generate in ScanExpress TPG will be automatically loaded into ScanExpress Runner. You can also add additional ones into ScanExpress Runner. For example, if I have an SVF to program a Xilinx component or something like that. So add and remove, individually enable or disable. So if you want to disable a test step without removing it from your test sequence, you can do that. And stop on failure. If I have a test step that even if it fails, I want to continue on after it. This can be useful for collecting statistics or like looking for an intermittent problem, rerunning the test, but don't stop if it fails, just see how many times it fails. You can use that option. We have an API for this software. Actually, a recent change that we made to the API is now asynchronous. So we have both a blocking and an asynchronous API. The asynchronous means that we can tell the software, run the test, you can go do other things, and then pull it until you come back and it says test is done. We have examples for LabVIEW, Lab Windows, Visual Basic, Python. So whatever third-party test executive you like to use, we might already have some examples. Even some of the things we don't list here, like C#, we have some internal examples for that. You can do individual test step flow control in the graphical user interface, or if you prefer more powerful, you can always call our API with something like test stand for additional instruments. All of our controllers include GPIO, and we can control those with ScanExpress Runner. We can either set them to a fixed value, like based on if a test step fails, change its value, or specify a value prior to executing a test step. We can also control those with script type test steps, where we can wiggle the IO pins based on what the script says. And we can loop test steps. In fact, we often will loop our infrastructure test, and the infrastructure test is testing how well the scan chain is working. So for example, it's reading IDs, making sure that we can send instructions. If you loop that maybe 1,000 times, you get a good idea of whether that system is working, whether we have good communication with the board, good signal integrity, and everything is working. If you have a third-party programming file from your FPGA or CPLD vendor, we can load that in. It's really easy. You can just drag it onto that main interface or go to that test step configuration window or test plan configuration window and add it there. So the two main formats are Jam Staple, which is a JEDEC standard, and you'll find that Altera supports that very well, or Intel FPGA now. And SVF is serial vector format. We tend to recommend, if you're using Xilinx, to use the SVF file. Staple JAM has the advantage of being more of a script language, which includes things like if, else, and for loops and while loops, which means that for programming an FPGA with the JAM file, they can do things like, say, start programming and then poll until done. In the case of SVF, it's more of a vector pumping approach. So it's a pattern of expected and actual. That means that SVF, instead of being able to poll for done, it has to use worst case scenario timings and just assume that by the time it moves on to the next step, things will be done, which means it's not going to perform as well as Staple would. The files that we use for ScanExpress Runner are inf.cvf, and notice that these are they're extended extensions, so they have a suffix plus an extension. We do require that this suffix be included, so for an infrastructure test, it does have to have _inf.cvf. So the main tests: infrastructure, interconnect, bus wire, resistor, pull up, pull down. Those are each CVF type test steps with their own additional suffix. Cluster, script, and memory test, also CVF files with additional suffix. Thanks for watching. For more information, visit our website at Corelis.com.